All right, a couple more similar examples. So same directions and same given values, right? 2 points. So number 31, um, same thing. I'm gonna just kind of either in my head or on paper, just label x1 and y1 as well as x2, y2. So then I'll find the slope because I have a, right, if I'm using point slope form, I have the points, but I just need the slope. So I'm going to do y2, -4, minus y1, which is -1. So remember that we have a negative built in our formula, our slope formula, but we also have a -1 that we're plugging in, right? So we end up with a negative situation, which negative turns into a positive. Then on the bottom, we're going to do x2, 3, minus x1, which is -2. Okay, so we have another negative, so that's going to turn to a positive. So we end up with -4 plus 1 on top, which is -3. On the bottom, 3 plus 2 is 5. So -3/5 is our slope. So when we plug it into our formula, it'll be y minus y1. So remember when there's a negative built in our formula once again, and then we're plugging in -1 there, right? So that's where we get the double negative. It turns to a positive. So then equals the slope, -3/5, times the quantity of x minus x1, right? So we have another double negative going on there because we're plugging in -2 for x. All right. So I'm just going to kind of rewrite it all, clean it up. Those double negatives, make them into positives. So now with standard form, we want to get rid of the fraction. So I'm going to multiply each term by 5. And each term outside the parentheses, right? Can't mess with the value inside the parentheses. So we can see here that 5 times y is 5y, 5 times 1 is 5. The 5's will cancel out here. And so we'll just end up with -3 times the quantity of x plus 2. And so now we can distribute. So we get 5y plus 5 equals -3x minus 6. All right, so now we want to get this in standard form. So I want my x and y on the same side, but I want the x term to be positive, right? So here I have -3x. So I'm going to move it to the left to make it positive. So I'm going to add 3x to both sides. Okay, so then the y is already on that side, so I'm just going to leave it there, and then I'm going to subtract 5 from both sides. So we get 3x plus 5y equals, and then these cancel out, and -6 minus 5 is -11. All right, and that's it. So we have positive x coefficient, and then we have a, b, and c all integers, no fractions, no decimals. So so that's standard form. All right, now 35 is unique for a different reason. So here on 31 we had more negatives in the mix, and so that's kind of why I wanted to show you one like that, just to show you what to do in those cases. But 35, when we find the slope, well, let me go through the process here. x1, y1, x2, y2, and you might already recognize what the issue is or the difference here, but if you don't yet, you'll see it here in a second. So when I do y2 minus y1, 6 minus 4, no big deal. But on the bottom, I'm doing x2 minus x1. So here's where the issue comes in. So we have 6 minus 4, which is 2. But on the bottom, we have 2 minus 2, which is 0, right? So that means we have undefined slope. Okay, so m is undefined. So you might have recognized right from the start that we had the same x coordinate for each point, right? When that happens, that means that if you think about the graph, it's not moving left and right, right? One of the points is 2, 4, right here, and the other one is 2, 6. So it's a vertical line, right? So, so you can actually figure that out at this level without having to do this work, and I'm fine with you doing that, especially if you circle them, and that'll show me that you know why it is what it is. But as soon as you see that happen, we know we can't write this in slope-intercept form like we saw before. And really, point-slope form is hard because we need the slope, right? And the slope is undefined. So what we're going to do is just write the equation as we know that whenever we have a vertical line, it's x equals a constant, right? And that constant is whatever the value on the x-axis that the line goes through, right? So in this case, the constant is 2, right? So in other words, x is always 2. So that's our equation, x equals 2. Okay, and that actually is in standard form, right? So we don't have a y, so we can think of it as 0y, x plus 0y equals 2. And so this is actually our answer. Okay, so this one you can actually go straight to the answer once you recognize, oh, my x coordinates are the same. So it's just going to be x equals 2. All right. All right, so for 37, what do you notice about this one that's unique? And if you guessed it, congratulations. Yeah, then the y coordinate is the same this time, right? So what kind of line is that when the y coordinate's the same? If you think about it on the graph real quickly, think of this is where y equals 9. And so we have x equals 3 and negative 3, right? So one point is here, 3, 9, and the other one is negative 3, 9. So here we have a horizontal line, right? So how do we write an equation of a horizontal line? It's, there we go, y equals the y-intercept, right? Which in this case is 9, right? Y is always going to be 9. And so once again, that's already standard form. And so that's our answer. Okay, so those are a couple special cases where we saw when the x-coordinate's the same, it's going to be a vertical line. So we just put x equals whatever the x-coordinate is. That remains the same in that standard form. And it also works when we have horizontal lines. When the y-coordinate's the same, we can just put y equals the y-coordinate without showing any work, right? And that's standard form, okay? Because here x is, or the value in front of x is 0, right? 0x plus y equals 9. All right. Let me know if you have any questions.